So the next one we have, after the product rule, the next one we have is a quotient rule. So this quotient rule, how are we going to identify that if a problem comes in form of fractions, then mostly questions that come from fraction, we can use a quotient rule to solve it. So I can derive the formula as well using the false principle too. So from here, let y is equal to uv, just like what I mentioned at the product rule. You know, I told you there is something that we need to take care of. You can only have u plus, even though you have u plus change in u, this is 0, or v plus change in v, this is also 0. Or when you have change in u and change in v, this is also 0. So there's nothing like that. So now, so here we can have y plus change in y. So this is u, we can have u plus change in u. This one too, v plus change in v. So if I correct the like terms, making your change in v as the subject, we have the y equal to u plus the u, change in u, v plus change in v. This is plus y. When it comes here, it's going to have minus y. So here we can have change in y is equal to u plus change in u all over v plus change in v. So our y is nothing but u over v, right? So now, by taking the XCM, to combine them together, we have change in y. So XM of this is going to be v bracket over v plus change in v. You know, you take the XCM, this will multiply this one will multiply this. So that means that we have v bracket over u plus change in u minus u bracket over v plus change in v. So what did I do there? I only take the XCM. XCM will be when we combine them together. So this will multiply this at the same time. This will also multiply this. That's why we have v bracket of u plus change in u minus u bracket over v plus change in v. So now, if I do that, if I open the bracket, I can have that one to be change in y is equal to v times u. We are going to have uv, v times change in u, and we have v du minus u times v. We are going to have minus uv minus times plus. We are going to have minus then u change in v all divided by v times v. We are going to have v squared. V times change in v, you are going to have v change in v. You know, I told you earlier, there's nothing like v change in v, so we can remove this, remove that, and we have this. So now, so here you can have change in y is equal to, so uv minus uv, what are we going to have there? Yeah, we're going to have 0. So if I have 0 there, what do we have left? So what we have left now is v du minus u dv all divided by v squared. So now normally we divide all through by dx. And we do that under the first principle. You know, I told you if you have this, if you have divisions, it can change to multiplication. So when it change, it can only affect the one we have at the numerator. So that means here we have the y dx of this is equal to v. Okay, I will not jump a step. U minus u dv over v squared multiplied by 1 over dx. So as I told you, you know, it can only affect the one we have at the numerator. So if you do that, so here we are going to have the y dx of this to be this of this, and we have v du dx minus u dv dx all divided by v squared. So this is the formula for quotient what? For the quotient rule. So just like the way we do under the product rule, if you are given a problem, you let the one you have at the numerator to be u, let the one you have at the denominator to be v, then differentiate them one after the other and plug them to the formula. So therefore, in general, so in general, we can have, that is the y dx is equal to v du dx minus u dv dx all divided by v squared. So this is the formula for the quotient rule. So let's see a question from Federal University Duze. They say if y is equal to 4x cubed minus 7x squared minus 2 divided by 3x plus 5, and we are asked to find dy dx. So how are we going to go about that? So as I told you, just let the one you have at the numerator. So this one is going to, how we are going to solve that? We'll solve it using the same method. This is going to be my u, and this is going to be my v. So this u is equal to 4x cubed minus 7x squared minus 2. Then v is equal to 3x plus 5. So I will differentiate the first one, and I will also differentiate the second one. So here we have u and x. That means that we have du dx is equal to the differential of this, differential of 4x cubed, we are going to have 12x squared, right? So differential of minus 7x squared, 2 times 7, that's going to give us 14x, and differential of 2 is going to be 0. So here, v and x, and we have dv dx is equal to differential of 3x. What are we going to have? Yeah, we're going to have 3, and differential of 5, that's going to be 0. So now, the formula, dy dx is equal to v du all over dx minus u dv all over dx, all divided by v squared. So if I plug that one, I can have this one to be, so from here our v is 3x plus 5. Du dx, we have this result to be 12x squared minus 14x, then minus u. Our u that we have is 4x cubed minus 7x squared minus 2. Our dv dx, what do we have at dv dx? dv dx is 3. Then all divided by v squared, which is 3x plus 5 all squared. So if I open the bracket for this one, if I open bracket, so here you can open the bracket of this one. 3x times 12, that's going to be 36. So x times x squared, that's going to be x cubed. Now 3 times 14, that's going to be minus 42. Then x times x, of course, we are going to have x squared. For the second one now, 5 times 12, we are going to have 60 x squared. 5 minus 45 times minus 14. So here we have 0. 5 times 1, we are going to have 5 plus 2. So let's see this one. 16, 5, 60, 14 plus 5. 5 times 1, 5. This is 70. So it is minus 70x. What are we doing here? We are just expanding 3x times 12x squared. That's going to give us 36x cubed. 3x times minus 14x, and we have minus 14x squared. 3x, 5 times 12x squared, and we have 60x squared. 5 times minus 14x, and we have minus 70x. So now this one is like, we want to open the minus times 6, and we have minus 3 times 4. That's going to give us 12x cubed. Minus times minus, and we have plus 3 times 7, and we have 21x squared. Minus times minus, of course, I will still have plus 3 times 2. We are going to have 6, all divided by 3x plus 5 all squared. So let's look at the one that have the same power together, the one with the same power. 36x cubed minus 12x cubed. Of course, if you do that, we are going to have 24x cubed. So the one that have square also, let's check the one that have a square. This, at the same time, these two as well. So if I do that, if I have minus 42x squared plus 60x squared plus 21x squared, what I have here is 39x squared. Then you can see out of all these variables, this is the only one that have x. So that is a minus 70x. Then you can see we have 6 plus 6, all divided by 3x plus 5, all squared. So let's see another problem from okay, let me derive another questions. Let me derive another one more questions using quotient rule. But you know, in some cases, one function can be in the other one. We are coming to that maybe immediately after we finish all those ones. You will see when we have a problem, maybe you can see you'll be asked to use exponential and it need for you to use a quotient. Let's look at this one. We say if y is equal to x plus 2 over x minus 2, we are asked to find dy dx. Of course, since you see like it's just a quotient, those fractions, I can see you the same thing. Let u to be x plus 2 and let v to be x minus 2. So the same way, u and x, and we have du dx is equal to 1, right? Because differential constant is 0. So v and x here too as well. Du dx, and we still have 1. So the formula is dy dx is equal to v du dx minus u dv dx, all divided by v squared. So let's plot the value that we have one after the other. So our v that we have from here, our v is x minus 2. So down here we have x minus 2. Du dx is 1. We have 1 minus u. Our u is x plus 2. Dv dx that we have here is 1, all divided by v squared. We have our v to be x minus 2 all squared. So now if I open the bracket of this one, 1 times this, and we have x. 1 times minus 2, and we have minus 2. Minus times x, and we have minus x. Minus times plus 2, and we have minus 2, all divided by x minus 2 all squared. So now x minus x, what are we going to have there? Is 0. Minus 2 minus 2, and we have minus 4, all divided by x minus 2 all squared. So we can see that's all we have for the what? All we have for the quotient rule. Now we have done the general method at the same time using the function of function, which is chain rule, product rule, first principle, at the same time the quotient rule.